In this video, we are going to start the second part of our module, which is about sequences and series. I would like to start with sequences of real numbers and give you a few examples and the definition. So what do I mean by a sequence of real numbers? Well, to put it simply, it's just a list, an infinite list of real numbers, which goes something like this: A1, A2, A3, and so on. So it is an infinite list of ordered real numbers with an standing for the nth term, nth number in the sequence, in the list, and it's a real number for all indices n. So let's look at a few examples. The first example I would like us to consider is an being equal to n for, well, all indices n, which are natural numbers. So this is quite simply the sequence of natural numbers. So a1 is equal to 1, a2 is equal to 2, the third term in the sequence is equal to 3, and so on. The sequence of natural numbers. Well, let me give you another example. Let's use this time k for the index, the letter k, and I would look at the index which has the kth term being equal to 2k. Again, k runs through the natural numbers. So what is this sequence? Well, it's just double the index. So it is the sequence of even numbers, the first one being 2, the second term in the sequence is 4, the third one is 6, and so on. You get the idea. So this is the sequence of even natural numbers. Okay, for the third example, I would like us to consider the following sequence. ak, this time, is equal to 2k minus 1, as k, the index, runs through the natural numbers. So what is this sequence? Well, I would like you to pause the video, think about what this sequence is, what is this list of numbers, and give me the first term in the sequence. That is the fifth term of the sequence. So give me the fifth term of the sequence by pausing the video and entering it in the box below. Okay, I hope you paused it and have found that it is twice 2 times 5 minus 1, so that is 9. And you have hopefully realized that this is the sequence of odd natural numbers. So a1 is equal to 1, a2 is equal to 3, and so on, a5 being equal to 9. So the sequence, so let me just write odd natural numbers. So in these three examples, you have seen sequences which were given by a simple formula. So you wanted to get the nth term of the sequence, well, you just simply use this formula. You wanted to get the kth term of the sequence, well, you just use this formula, and so on. You wanted to get the fifth term of this particular sequence, well, you just had to use the formula which I've given to you. So these sequences are explicitly defined because there is a very simple formula giving you the general term in the sequence. Okay, let me give you an example of a sequence which is not explicitly defined. I shall maybe make a note here. So these are explicit formulas. And I shall give you an example of a sequence which is not explicitly defined, you have all probably seen this sequence. It starts with the first term being equal to 1, and so is the second term in the sequence. And after that, the nth term of the sequence is obtained by adding the previous two terms. So this is true for indices n equal to 2, 3, 4, and so on. Okay, you have all seen this sequence, I hope. This is the sequence of Fibonacci numbers. And again, I would like you to pause the video and give me the fifth Fibonacci number, the fifth term in this sequence. Okay, I hope you paused it and have found that this is not as easy to find as it was in the previous example, because first, in order to get the fifth term, first you have to have all the terms coming before that, because there is this formula which tells us that in order to get the nth term, we need the previous two terms. So with having the first and second term, I can certainly calculate the third term being the sum of the previous two, so that's 2. Then the fourth term is the sum of the previous two terms, that's 1 plus 2 equals 3, and then I can calculate the fifth term being the sum of these two. So it is, let me write it over here, this is F5, the fifth Fibonacci number is 2 plus 3, 5. So these are Fibonacci numbers. Okay. So before we end this video, let me just point out that such a sequence is called implicitly defined. So this is an implicit way of formulating a sequence. And before I end this video, I would like to give you the definition of a sequence, well, the more rigorous definition. So a sequence is of real numbers is a function A mapping going from the set of natural numbers to the set of real numbers. So this really means that we take each natural number and map it to some real number an. This is how we can precisely define what do we mean by a sequence of real numbers. And we usually, if we want to denote the entire sequence, so this is our notation. If we want to denote the entire sequence, we use an in brackets. Okay, so I hope you enjoyed this video, and I'll see you in the next one.